Hello everyone. Today we will discuss a second part of time value of money. This will give you a basic idea about the time value of money. As we discussed earlier in previous lecture that how to calculate future value and present value. So I'm just giving you a review that these are the terms we will use. APR stands for annual percentage rate or the nominal rate, whatever given in question as annual rate. PV stands for present value. FV stands for future value. We will use R for the discount rate and M for the number of compounding period. In this lecture, M will play very important role, and this will be our focus point. What is the concept of M and how we use it in our questions? N will be used for a number of years. Look, this is the formula that we did in the previous lecture, that if anybody is interested to find out future value, then we use this formula. We will need present value and we will use 1 plus r to the power n to calculate future value. Suppose you are interested to find out present value, then this is another formula which is conversion of future value, in which you will take future value and divide by the present value factor, so you can get the present value answer. Let's suppose this is the question which is given, that a person deposited 100,000 today and bank promised to pay 126,000 after 3 years. What rate offered by the bank? Actually, question is interested to know that if a person is depositing this amount and bank promises that bank will pay to that person 126,000 after a certain time period, then what is the actual rate offered by the bank? Because we know the time period, we know the amount we will receive, we know that what we are depositing right now, but the rate is missing from the question. So if we only interested to know the rate, then this is the data which is available. Present value is the amount we deposited. Future value is the amount bank promised to pay after 3 years. This is the number of years, and we are interested to find out R. To calculate R, we will convert the formula and look that we are actually using the same formula of future value is equal to present value 1 plus R to the power n. But after conversion, the formula will be structured like this. Future value will be divided by present value, and n will be converted into fraction as a power 1 upon n. If you have a scientific calculator, you can use that one to find out factor over here as a power. And later, as I discuss that, I will further present these time value concepts on Excel. So those lectures will be available for you when you have subscribed this channel and press the bell icon. Then you will see that how we will use this function on Excel. That is quite handy to solve the issue. But right now, if we put feature value over here and divide it by 126, so this is the look of the solution, that 126 divided by 100,000, and the power is coming 1 divided by n, and n be taken as 3. So when you will solve it, it will become in decimal 0.33, and when you will solve it on calculator, n minus 1, so you will get 0.08. Might be the answer will not come in terms of percentage, your answer will be coming in terms of 0.08. So if your answer is coming in 0.08, you can multiply that answer by 100 to convert that 0.08 into percentage. This I will further explain in Excel, that how we convert it into percentage. But I think that if your basic mathematics is clear, then you can easily understand that 0.08 may be called as 8%. Now, as I discussed in the previous lecture, that once a question is appearing on a slide during lecture, you can pause the video and try to solve it yourself and see that can you get the same answer or not. So over here, you can pause the video and try to solve it yourself and then get the idea that how the solution is appearing on video. A person deposited 200,000 today and bank promised to pay 400,000 after 5 years. Now, technically, we are doubling the amount. We deposited 200,000 but getting 400,000 in 5 years. So what is the rate which actually offered by the bank? So this is the data which is available. Try to solve it yourself. You can pause your video over here, and this is the formula that we are using. And student, this is the answer that you will be able to obtain. Again, reminding you that if you are working on calculator or on Excel and suppose your answer is coming 0.1487, then you can multiply that answer by 100 to get the percentage. Otherwise, in both cases, your answer will be correct. So this is the way to calculate in any question where rate is missing from the question. There is another concept which is called effective annual rate. Many students get confused when they work on annual percentage rate and effective annual rate. Technically, these are two different things. Annual percentage rate is the rate which is generally offered by any financial institution, and at that time it is not necessary that they actually tell you that what is the effective annual rate. Effective annual rate can only be understand if you understand that how many compounding intervals financial institution is doing within a year. Like right now I'm giving you an example that annual percentage rate is given 10%, compounding intervals half year. Half year means bank will not give you interest at the end of the year. Bank will not give you profit at the end of the year. Bank will calculate this interest or this profit in two intervals. One at the end of the 6th month and then at the end of the year. To demonstrate you that how we work on this concept, I am taking a demonstrating amount of 100 and see that how the work will appear. Remember that this is important that compounding intervals are 2. If it is appearing 2, it means that you are actually depositing 100 and you will be able to get 5% interest on this. Why 5%? Because your annual rate is 10%, but bank is not giving you interest after a year. Bank is giving you interest after 6 months. Why after 6 months? Because bank is compounding on a half yearly basis. So financial institution will give you half of the interest at the end of 6 months. Once you get this interest, the total amount in your account will become 105. You can calculate it yourself, take the 100 amount and get its 5% and see that the arriving amount will be 5. Now student, after 6 months, we have amount of 105 in our account. So when bank will reach at the end of the year, bank will use this amount rather than working on your actual deposit. And from here, the concept is changing. So when bank will use this amount and apply 5% interest on this, so carefully see that now the interest amount that you are receiving is comparatively more than what you were actually getting earlier. So the total interest that you will be able to get now is 5 at the end of the 6 months and 5.25 at the end of the year. So the total interest that you will be able to receive is 10.25. See that this 10.25 is more than what you were actually getting if you simply take 100 and apply the 10% rate. If you take this 100 and apply 10%, so you can verbally do it that the amount should come as 10 rupees rather than it is coming 10.25. Now suppose repeating the same concept and now the amount is 100, but now the bank is compounding on a quarterly basis. So once bank is calculating on quarterly basis, it means that every interest will be calculated at the end of 3 months, and its manual calculation will be like this. Naturally, when you were doing work on Excel or when you are calculating it, you don't need to demonstrate it like this, but this is only for your understanding that how on the back of the bank, how they work and how they perform this activity. So look, they are actually, you are depositing 100 and the interest amount that you will receive is 2.5. Why I am taking 2.5 percentage? Because the rate of interest was 10%. It is compounding on quarterly basis. It means that this rate will be divided into 4 parts. So when you will divide this 10 by 4, your quarterly rate will come 2.5. And in this way, the amount you will get will be 2.5. But for the next quarter, bank will not use this amount. Bank will be using this amount to calculate the second 2.5. If you will check it on your calculator, you will see that now if you apply 2.5 percentage of on this amount, the resulting amount will be slightly higher than this one. Look, this was coming 2.5 because we applied this percentage on 100. But now we are applying 2.5 percentage on this amount. When you will apply 2.5 percentage on this amount, you will get interest of 2.56. Again, reminding you that if you like to work it yourself, then you can hold your video over here, pause it and calculate it yourself on calculator. And just I'm moving forward, keeping my pace slow. So now the total amount in your account is 105. Now think, if I have 105.06 in my account and bank is giving me again 2.5% interest, then how much interest I will be able to receive at the end of 9 months? So now you will calculate on this amount. Look, this is the amount I have. I will calculate on this amount. So now the interest amount will be slightly higher than the previous one, and you can uh, calculate it yourself on calculator. So the total amount in my account will be 107. So again, check it that now at the end of the year, the interest amount will come on this amount. So if I have 107,000 and I apply the same 2.5% rate on this amount, so 2.5% will give you 2.69 interest. So student, in this way, we will be able to get 110.38 at the end of the year. So this demonstration can help you to understand that as number of compounding intervals we will increase, we will be able to get more interest as compared to the previous condition. So as you have seen the two examples in which we showed that in the first example you were able to get two intervals, and in this case you can understand it through four intervals and so on. So this is the actual pattern that we are working on. If we are working on a yearly basis, it means that we are having only one interval. If we are working on a half yearly basis, it means that M, the number of compounding intervals within a year, should be 2. If we are working on quarterly basis, the number of compounding intervals will be 4. If we are working on a monthly basis, the number of compounding intervals will be 12. And on daily basis, we will have 365. Now think, if we are doing it on continuous basis, then what will happen? This of course is an advanced topic, not discussing it here. Now check this one. Consider APR 10%. APR means annual percentage rate is 10%. With half yearly compounding, what is the effective annual rate? EAR stands for effective annual rate. So if annual rate is 10%, but financial institution is compounding on a half yearly basis, then your effective annual rate will not be equal to APR. This is the technique that you will apply to calculate effective annual rate. Again, you can apply it on your calculator to see it's working. APR is coming 10 percentage, and M, as indicated earlier, M is showing how many compounding intervals you have in a year. So right now M will be taken 2. Why 2? Because we have half yearly compounding. It means that 2 compounds will be occurring in a year. When you will apply this M again here, which is 2, it means that if you are keeping M4 here, then 4 will also come over here. If you'll apply 12 here, then 12 will also appear over here. Then apply it on calculator -1, and your answer will be appearing exactly like this. When you will multiply this answer by 100, you will be able to get 10.25 as your answer. Now again, check it yourself. Pause your video and see that can you solve it and can you calculate the effective annual rate when APR is 10%. I'm sure that with a slight effort you can solve it yourself. So this is the solution. Now carefully see that since quarterly compounding is given, so I am taking M as 4, and the 4 will come over here and 4 will also come over here because we need M here as well as M over here. Your calculator will be giving you answer like this that you can convert into effective annual rate by multiplying by 100. I will show this working on Excel too, and to uh, get that video, it's better to subscribe the channel. Then you will be able to get access of my Excel working that I'll show you. It's quite handy. There will be no problem. Now see that APR is given 10% with monthly compounding. When monthly compounding is given, it means that now M will be taken as 12. Again, you can try it yourself, and once you are make sure that your work is clear, then you can check the working and you will see that I am taking M as 12. Why 12? Because it is based on monthly compounding. Once 12 will appear over here, 12 will also appear over here, and you will successfully get answer of 10.47. This is very interesting idea, and this is important if you are trying to solve various MCQs, you are trying to solve various logical questions, that if compounding interval is given on a yearly basis, then APR will always be equal to effective annual rate. Both rate will be same. But as you will move compounding interval from yearly to half yearly means now you are working on as M taken by 2. Then APR if 10%, then effective annual rate this will not be equal to APR. This will be slightly higher than APR rate. In a similar way, if you are moving to quarterly compounding and APR is 10%, then this rate will be slightly higher than this, as well as if you carefully observe that this rate is also higher than the previous one. And in similar fashion, if you're working on monthly compounding intervals, then your rate will be slightly higher. Just giving you another one very simple question. This will help you a lot when you are facing this type of situation. Now check, bank is compounding on a quarterly basis. This is important because if bank is saying that they are compounding on a half yearly basis or they are compounding on a monthly basis, so this information will play very important role to understand and solve the question. How much we will have after 3 years? So of course bank is compounding quarterly, but now you are not interested to get the amount at the end of the 1 year. You are interested to find out how much will you have after 3 years when your deposited amount is 1000 at a rate of 15%. Remember that this rate whenever is given, it is indicating APR. This is annual rate which is given. If This nomenclature will not be applied on the question, then question setter will provide you some support. So whenever no information is given and some rate is available, then this rate is always taken as annual rate. Now this is the data that will appear with the help of this question. Now look that M is coming 4. Now think that why M is coming 4. This is important. And think and link with your question that present value is 1000, rate is 15%, N is 3 years, and from where M is coming 4. I think you can judge it. Bank compounding quarterly. So in 1 year we have 4 quarters. So based on this information we are taking M4. And now question is interested that how much you will have after 3 years. It means we are interested to find out future value. So you will apply a slightly modified formula. You will again use present value. You will take R as 0.15, M as 4, and carefully check that in power you will be using N multiplied by M. So this is the part where your question is slightly changing. You will be very careful when you are putting power, that power is not only taking M, power is also taking N. So showing you it's working. So 1000 deposit amount 0.15, M is coming 4, and this part is tricky. Why 3 multiplied by 4? 3 showing your number of years and 4 showing M. M is standing for number of quarters that you are using in the question. So you will be able to get an answer of 1,555.45. I do hope that my lecture will give you a basic concept of effective annual rate and how to calculate rate if it is not given in the question. Subscribe the channel, like it, and you will get more interesting videos for your future academic activities. Thank you.